All right, IBSL1. We are back today to talk about the first part of 1.3, which is all about series. So, first of all, what a series is, it's just adding together terms in a sequence. So you can have arithmetic series, geometric series, or any type of series. Like you can take a sequence that's non-arithmetic and non-geometric and add them all together, and that it technically is a series. But today we're going to mainly focus on arithmetic series and geometric series. So, you guys, truth be told, I don't always remember the formula for an arithmetic series, but I do remember this little story about one of my all-time favorite mathematicians, Gauss. So the story goes that Gauss, back in like Germany in the whatever hundreds, was in this little schoolhouse, and the teacher was trying to punish the class for being too rowdy. And so, she told all these 6 and 7-year-olds to like go back to their desk and take out a piece of paper and add all the numbers from 1 to 100. So that would be 1 plus 2 plus 3 plus 4 plus ... 96 plus 97 plus 98 plus 99 plus a hundo. So, little Gauss, 7 years old, goes back to his desk, and, they didn't have calculators back then, but he had the answer within minutes. So, the way little Gauss figured this out is basically with an arithmetic series formula. So, the way he did it is he saw that you don't have to add these in order. Like, most students would probably add 1 plus 2 is 3, and then another 3 is 6, and then a 4 is 10, and then a 5 is 15. But you don't have to add things in order. You can put them in any order. So Gauss said, well, what if you just add the first and the last term? That would be 101. And then add the next pair. That is also, 101. And then 3 and 98 is another 101. So you have like all these pairs of 101 all the way down. And you have, half the pairs of however many things there are. So Gauss said this sum would be S sub 100. This means adding together 100 terms. Would be, there's 100 pairs. Not 100 pairs, there's 100 things, so there's 100 over 2 pairs, and then the first term plus the last term. So this would be, 50 times 101, so this is 50. Very quick. You guys, this right here is essentially one of the arithmetic series formulas. So, let's go back to orange. An arithmetic series formula one of them is S sub n equals n over 2 times u sub 1 plus u sub n. The way you can think of this is that this is like the first term, and this is the last term. This is the Gauss method because that's the way he did it. He said the first term plus the last term is going to be the same as all those pairs. So first term plus last term. And that there's n over 2 pairs. That if you have n things being added together divided by 2, that's how many pairs you have. So this is one formula. So let's put a little box around it. This is like one way to do an arithmetic series. But you guys, depending on what information they give you in the problem, it might be more advantageous to use a rearrangement of this formula. Because u sub n is the same u sub n from an arithmetic sequence, it's like a term in the arithmetic sequence, we know that that arithmetic sequence is u sub n equals u sub 1 plus n minus 1 times d. So what we can do is we can sub that in the equation and then clean it up to find the other one. So an alternate version, still keep that n over 2, still keep that u sub 1, but then this whole part right here, we're going to replace with this whole part right here. So this becomes u sub 1 plus n minus 1 times d. Then you have a couple like terms here. U sub 1 and u sub 1 added together are 2u sub 1. So this is n over 2 times 2 u sub 1 plus n minus 1 times d. This is the second version of an arithmetic series formula. So you might ask yourself, well, why would I use one or the other? Well, it really depends on like what information they give you, and we'll get into it with the examples soon. For a geometric series, there is a proof of it, but it's not fun like the Gauss story, so rather than bore you guys, I will just give you the geometric series formula. A geometric series, there are two different versions, but they're kind of the same thing. It's still S sub n. I always think of capital S as standing for sum, because all series are sums, is the first term times 1 minus r to the n all over 1 minus r. An alternate version of this is these two guys and these two guys can switch places. So another way to write this, it's not really different, it's just kind of an algebraic rearranging, is r to the n minus 1, but then you have to keep that pattern on the bottom, and so it's r minus 1 down here. These are both geometric series equations. So you just need to know the first term, the common ratio, and how many terms there are, how many you're adding together. All right. Sorry. If you need to look at that, write them down. Those are our toolbox for the day. First up, find the sum of 159 plus ... all the way up to the 8th term. The first thing I notice is that it's arithmetic. It's going up by 4 each time. So I'm going to use the arithmetic series, sorry. So if I'm going to find 8 terms, S sub 8, that's going to be n over 2, which is 8 over 2, 2 times the first term, which the first term is 1, plus n minus 1, but the n is 8, so we can do 8 minus 1, times the common difference, which is 4. Then it's kind of all, just simplifying, cleaning up. So this is 4, 2, plus 7 times 4. So this equals 4, that's 30. So this is 120. So the first 8 terms together added are 120. Notice that I use the n over 2, 2 times u sub 1 plus n minus 1 times the common difference because we didn't know what the 8th term was. If I had known what the top term was, then I probably would have used the Gauss method where you just add pairs. But since we didn't know the top, I just diverted to the other formula. Next problem. Well, how's it changing? -2, -4, -8. This looks geometric to me, that it's getting multiplied by +2 each time. So, if we're going to find the first 9 terms of a geometric is the first term times 1 minus r to the n. So the r is 2, and the n is 9, all over 1 minus r. 2 to the 9th, gosh, that's going to be a really big number, you guys. So, let's see. Yeah, if you start to simplify this becomes -2, and then 1 minus 2 to the 9th is 1 minus 512. And that's a -1 on the bottom. But then this -1 and this -2 will cancel, well, the negatives will cancel each other out. And 1 minus 512 is -511. Oh, did they make a mistake in the book? I think they did. Oh, no, they didn't. So the whole thing will be negative. -1022. So S sub 9 equals negative. That's 2 times the -511. Next up, 100 plus 50 plus 25 plus the 6th term. Once again, how is it changing? Well, it's getting multiplied by a half. Hopefully you guys can see that it's getting halved each time. So the multiplier is a half. Don't say divide by 2, say multiplied by a half. So I'm going to use the same equation again. S sub 6 is the first term times 1 minus the common ratio to the power of n, but the n is 6. And this is all over 1 minus the common ratio, which is 1/2. Let's see, how deep we want to go with the fractions. Yeah, let's run with it. Okay. Let's see. I'm going to let that 100 hang out. On the bottom, 1 minus 1/2 is 1/2. Inside the parentheses here, this is going to be 1. So the 1/6, or the 1/2 to the power of 6 is 1 to the 6th and 2 to the 6th. So the top, 1 to the 6th is just 1, but then 2 to the 6th, I do not know offhand, but my calculator tells me is 64. I guess I should know that one. So far, so good. Now, here we will need a common denominator. So that's like 64 64ths minus 1 64th, which is 63 64ths. Also, this, I'm going to do 2 moves at once. 100 divided by 1/2, when you flip the bottom fraction, becomes a multiplier of 2. So that's 200. So this is 200 times 63 64ths. Is that too many moves at once? Might be. Did I make a mistake? No, we're good. So then I would probably just punch, well, you would multiply straight across to get, you know, well, you could cancel out a factor of 2 here to get 100 times 63 over 32. And then I guess you could cancel out a factor of 2 again. So this would be 50 and 2 down here. So that's 50 times 63 over 2. And why not? Let's do it again. Or no. Factor of 2, that should have been 16. My bad. That's what I get for doing math on the fly. And you could keep going that way, just reducing the fraction. But I think the next one is where it would reduce fully and then multiply on the top to get 1575 all over 8. So this is the sum of the first 6 terms of that geometric sequence. So it's a geometric series. Next up, 132, 124, 116. What are those? That looks arithmetic to me. Are they going down by 8? Yeah, they're going down by 8. So I'm going to use the arithmetic series formula. I don't know the top, so I'm not going to use the Gauss version. I'm going to use the expanded version. So that's S sub 7. There's 7 half pairs. The first term, 2 times the first term is 2 times 132, plus 7 minus 1 times the common difference. We said they're going down by 8. Boom. So that just becomes a calculator cruncher. I could go through the steps again with you guys, but really if you like punch that in your calculator and be very careful in using your parentheses. Like use more parentheses than you think you need. Like you can never go wrong with more parentheses, but you're more likely to get the answer right. This is 756. Next up. Ooh, first thing I notice is alternating signs. Positive, negative, positive, negative. That means that the common ratio in this geometric series is going to be negative. Now, a 1/8 turning into a 1/4. Remember that if you don't know what the common ratio is, off to the side, you could just divide a term on the left by a term on the right, and this will tell you the common difference. So, if you fraction divided by a fraction, you keep the top and then do the bottom fraction upside down being multiplied. I believe this all equals -2. Is that right? Let's see. If you multiply 1/8 with -2, you get -1/4. Yep, it works. So the first 12 terms is going to be the first term times 1 minus the common ratio, which is -2 to the power of 12, all over 1 minus -2. Let's see, how deep should we go with the fractions here? Yeah, let's run with it. What do we want to do first? I want to know what 2 to the 12th is. I mean, it's -2 to the 12th, but then because it's an even power, it'll just be a positive number. So this equals 1/8, 1 minus 4096, And then down here, a minus -2 is a positive 2, so this is all over 3. So far, so Gucci. Yeah, looks good to me. What do I want to do next? Let's see. I mean, subtract in here. So this would be 1/8. 1, take away all that would just be -4095. All divided by 3. But the 3/1, if you think of like the 1/8 being divided by 3/1, so you do your little multi-flip, flip the bottom denominator, which means this would be 1/24 times -4095. And then when you multiply that out and simplify, I believe the top and bottom are both divisible by 3. So this means S12 equals -1365 all over 8. But Mr. Jolly, can't I just do the decimal equivalent of that? Yes, you can, but really you should be getting more and more comfortable with fractions. This is not because I'm like on the fraction board and I'm pushing fractions on everybody. It's because like the more comfortable you are with fractions, the more successful you're going to be with higher level math. Like if you're reverting to decimals every single time, like cool, stick to science class, but math class is where like fractions reign supreme. Next up, oh, finally we get to do a little Gaussian method because we know the top term. So we're going to say, oh, you know what we don't know is how many terms there are. So we have to have a sidebar here. We have to pretend this is an arithmetic sequence, that these are all commas, and then figure out what term this is. So we have to use not S, Jolly, U sub n equals U sub 1 plus n minus 1 times d. We know 39 is some term. We know the first term is 5. We don't know the n value, and they're going up by 2. That's the common difference. Cool. Subtract 5 from both sides, we get 34 equals n minus 1 times 2. Some people might distribute that 2, but I'm going to divvy both sides by 2 and just get 17 equals n minus 1, add 1. That means that that is the 18th term. So S sub 18 equals 18 over 2 pairs, bottom term plus the top term. 9 times 44. 396. Cool, then we're done. This is the answer. Let's check the book, make sure I'm on point. Yeah. It's all good. Ooh, sigma notation came back on us. Let me think. If we look at this, do you guys see how this looks like a geometric sequence? Like first term times common ratio to the power of n? So rather than expanding that, we can just kind of jump to the geometric sequence formula, or series formula, because the sigma means that you're adding it together, so it's a series. I know that there's 15 terms, 1 to 15. I know that the first term is when you plug in a 1 for n. So -2, 3 times 1 is -6. So that means -6 is the first term. The common ratio is 3 because that's the multiplier in the equation to the power of 15 terms all over 1 minus the common ratio. Simplify the bottom to get -2. I'm not going to crunch 3 to the 15th yet because that's a very big number. But these two are 3. I know that. So this equals 3 times 1 minus 3 to the 15th. Will 3 to the 15th even work on my calculator? Oh my gosh, it's a big number. Let's look at the book, see what they did. Oh, they went with the big number. Okay. So 3 times 1 minus 1,434,8,907. Subtract 1, multiply by 3, then this will be -430467718. So just like -43 million. Oh, this was the first 15 terms. Last problem. Ooh, how's it changing? First thing I noticed, tops stay the same and the bottoms go up by 2. The signs don't change, so it's a positive common ratio. I don't know which term this is. Okay, so we know that the common ratio is 1/2 because the bottom denominators get multiplied by 2. But we don't know which term this is. Now, some people might be like, well, Jolly, you can figure it out pretty quick just by guessing, checking on your calculator. But I want to instill a little bit of algebra into you guys that we're going to use the geometric sequence equation to figure out what term it is. R to the n minus 1, is that how it works? Yeah. So, we don't know which term this is. The first term is 5/4. And the common ratio is 1/2 as to the power of n minus 1. I'm going to multiply both sides by 4/5 to cancel out the 5/4. These 5s go away. We get 4 over 256 is equal to 1/2 to the n minus 1. Oh, 4 over 256 must reduce. Yeah, to 1/64. So 1/64 is equal to 1/2 to the n minus 1. Then you could either use logs or you could guess and check. My brain's kind of thinking that 2 to some power is 64. Is it 2 to the 6th? Yeah, it is 2 to the 6th. So this whole side is 1 over 2 to the 6th, and this is 1 over 2 to the n minus 1. So 6 is equal to n minus 1, so 7. That means that all of that was just to figure out that this right here is the 7th term. So, S sub 7, first term, common ratio. There's 7 terms, all over 1 minus the common ratio. How much algebra should we do? Oh, yeah, let's go for it. Okay. So, let's keep a little divider here that I'm only working on this side. I'm going to let that 5/4 chill. This part right here, 1/2 to the 7th, just means it's 1 over 2 to the 7th, and 2 to the 7th is 128. That's not your marker. 1 minus 1 over 128. And then in the bottom, you get 1 minus 1/2, which is just 1/2. Next move, I'm going to do sort of 2 moves at once. I'm going to take 5/4 divided by 1/2, which using the multi-flip means this is 5/4 times 2 over 1. This is times 128 over 128 minus 1 over 128. So the second move I did was a little common denominator inside these parentheses. Now, these get a little cross reduction, so this becomes 5/2. 128 minus 1 is 127 over 128. And then I think we can just multiply straight across and reduce. So 5 times 127 is 635. 2 times 128 is 256. And I don't think that reduces. I think we're there. Okay, you guys. Wow, that was a lot. A lot of algebra, a lot of series. If you have any questions, please hit us up via email. Good luck on your homework. It's just one section tonight.